All right, so we're going to take a look at inequalities in this little mini lesson, and really what happens when I'm doing things with negatives, and then we're going to solve a few different problems. So let's take a look. We've got this inequality. We know for sure that 4 is most definitely less than 6, and so just remind yourself of the symbols. 4 is less than 6, and kind of read it from left to right. And what's going to happen when I multiply by a negative? Well, we know from equality that if I do something to one side, I have to do it to the other. And so notice that if I take negative 2 and multiply it by 4, and I take 6 and multiply it by negative 2, then I get negative 8, and I get negative 12. Now, there's a big problem here because if I just copy this sign, well, this is more negative, and so therefore it is a smaller number, and this is a larger number than this number for whatever reason. So we have to be really, really careful that when we're multiplying that we honor that, hey, this is going to flip. The sign is going to switch places because I multiplied it by a 2. And you'll find out that no matter what we multiply by, so long as it's negative, so let's say negative 1, times negative 1, we'll always have to flip the sign because the values change so much. So that's what happens when we multiply. So maybe it might be a good idea to write in your notes, when I multiply by a negative, what happens? And so if I were to answer that question, when I multiply a negative, I would say the sign flips. The sign, actually, let me change the wording. The symbol flips. And the symbol being the inequality symbol. So the symbol, the inequality symbol. All right, we're going to explore a few more operations. So we talked about it, what happens when it multiplies. Well, what happens when I'm dividing by negative 2? Well, we can do the same exercise again, and 4 divided by negative 2, and what we do to one side, we have to do the other side of the inequality, negative 2. So 4 divided by negative 2 is negative 2, and 6 divided by negative 2 is negative 3. Now take a moment, does the sign stay the same, or does it flip? Does the symbol stay the same, or does it flip? And hopefully, you've really concluded that negative 2 is a bigger number than negative 3 because negative 3 is more negative. So the sign actually does flip. So again, when I divide by a negative, I would write this in my notes, the inequality symbol flips. Now, I want to throw this in here because I think it's something that can kind of confuse some students sometimes. Well, what happens when I add negative 2? Well, if I add negative 2, so negative 2, I'm just adding negative 2, or some people call it subtracting, so this works for both addition and subtraction. Well, 4 minus 2 is 2, and 6 minus 2 is 4, and it looks like, in this particular case, the symbol doesn't change because 4 is definitely bigger than 2, or 2 is less than, we would read this properly, 2 is less than 4, which is also true. So when I add with a negative, the symbol stays the same. The symbol stays the same. And we could do this for lots and lots of little examples, but in general, when I'm adding negatives or subtracting with negatives, nothing changes. So that's going to be really important as we work to solve some inequalities, and sometimes it shows up and sometimes it doesn't. So just let's take a look at a few examples. So my goal here is to solve this inequality, and what I mean by that is what values of x make this true, and that's what solving is all about. So I want to group things together, so I want to get the x's all on the same side, and I'm going to get the numbers on the other side. Well, I notice that 9 is over here and 12 is over here, so if I subtract 9, then I'm going to deal with positive values and not have to worry about the symbol flipping. So I'm going to subtract 9x from both sides, and I'm going to combine only the like term parts. So we're left with, that cancels out, we're left with 4 is less than, 12 minus 9 is 3x minus 11, and then I have to add 11 to both sides, so plus 11, and we get 15 is less than 3x. And so then we'll have to divide by 3. And now I'm not dividing by a negative, I'm just dividing by regular 3. So 5 is less than x. Now what does this mean? It means that the things that work in here are values of x that are 5 is less than those values. So if I plug in 0, it's probably not going to work. This is going to come out with an untrue statement. If I plug in 5, well, that is also untrue. So we're going to actually do that really quickly off to the side just a little bit. So we're going to copy this whole equation down. So it's going to be 9x plus 4 is less than 12x minus 11. And we're going to substitute 0 for x. So it's going to be 9 times 0 plus 4 is less than 12 times 0 minus 11. And 9 times 0 is 0. 4, so this is 0. 4 is less than, well, that's 0. 4 is less than negative 12. So I plugged in a value 0 that was not true here. And when I plugged it in, it creates something that's not true. Well, 5 would do exactly the same thing. And so a good practice, and what I'm going to have you do is pause the video and practice substituting 5 in here and see what happens. It's going to magically appear. All right, so I substituted 5 in here, and I hope that you see that this statement, 5 does not work here. 5 is not less than 5. So when I substitute x for x and I try it back out, it's going to make something that's also not true. 49 is not less than 49. This is a false statement right here. And we just have to be really, really aware of that. So let's try something that isn't false. Let's try something that we know to be true. So we know that 5 is less than 7. So when I substitute 7 back into my original equation, it should be true. And now we're not going to do this every single time, but I just want to prove a point here. So 9x plus 4 is less than 12x minus 11. Well, if x is 7, so that's going to be 9 times 7 plus 4 is less than 12 times 7 minus 11. 63 plus 4 is less than 84 minus 11. So we get 67 is less than 84 minus 11 is 73. Hey, look, this ends up being a true statement, and it's because the x value was in that range. So I know that that's a little weird, and I just played with the idea. So remember that when you get an answer, it is the set of all the values that make it true. So I could put in 9 and it would work here. I could put in 22 and make it work here. So long as x is greater than, or 5 is less than x. Right, so we're going to try another one, kind of from a clean slate, to solve this inequality. And this is really what I'd like for you to be able to do. We're going to solve it so that we get all the x's to one side and all of the numbers to another. But this time I'm going to just subtract 4x, and I'm going to combine like terms. So x minus 4x is negative 3x. And I'm just going to try and prove a point here. So plus 8 is greater than or equal to, those cancel out, 17, positive 17. Okay. And then I have to subtract 8, so minus 8 from both sides. So I get the statement negative 3x is greater than or equal to 9. Okay? And then I have to divide by negative 3. Divide by negative 3. And it's really important, we go back to our notes from earlier. If I divide by negative 3, the symbol has to flip. So I'm just going to go ahead and do that right now. The symbol has to flip. And the negative 3's cancel out, so that's x. And 9 divided by negative 3 is negative 3. And so this is our solution. And just be really careful when you're dividing or multiplying by a negative number, both have to be true, then the symbol flips. So go ahead and try these two. I want you to practice this idea, but I also want you to do it on your own a little bit. These are a little bit more straightforward. Practice flipping the symbol if you need to. You don't always have to. But practice this for yourself. and then I'll show up in just a moment having tried some of them. Symbol flip. So we get x 7/3. And I know that it's a weird number, but it's the right number, so I just reduced the fraction. So 42 1/18, and I had my calculator help me out. I hope that you practice these and got a try for them just to see where you're at. All right, so this one's a little bit more complex, and I just want to pay attention that, hey, we actually have to distribute before we can simplify. So distributing is going to be our first step here. So why don't you pause the video to write the problem down, because it's a little bit long, and then when you're ready, you can continue to solve the problem with this. I'm going to combine like terms, so those are like terms. So we are left with 5x minus 10 is greater than or equal to x plus 26. Oh, excuse me, it's 8x plus 26. And then we're going to try and get all the x's to one side. So I'm going to subtract 5x from this side and from this side. So we're left with negative 10 is greater than or equal to 3x plus 26. And that means I also have to subtract the 26. Minus the 26, so we're left with negative 36 is greater than or equal to 3x, and then we got to divide by 3, and I'm dividing by positive 3, so I'm left with negative 12 is greater than or equal to x, and so things like 0 would not work here because 0 is a larger number, right? So this has to be the larger of the numbers. So it's anything more negative than negative 12. All right, last one. We'll go ahead and solve it. And this is just one last one. Go ahead and pause the video. I think you can do this one. All right, thanks for watching the video. I hope this was helpful in solving inequalities, just kind of getting your mind back into it. We'll see you next time.